Hello, everyone. My name is Ke Yang. I'm a PhD student in HCII from Carnegie Mellon University in United States. Today, I will talk about a technology ecosystem that allows students to transition fluidly and dynamically between individual and collaborative learning. For some background, as researchers start envisioning what the smart classroom of the future may look like, technology that support more sophisticated and personalized interaction may be able to bring about more learning benefits to students. In classroom, individual and collaborative learning are both common practice, and each have its unique merits and learning benefits. It may be fruitful to have students transition dynamically between individual and collaborative learning as the need arises for the given students. For example, if Chris is a middle school student who has been stuck in an individual assignment for a long period of time, instead of letting him to continually struggle individually, it may be helpful to pair him up with someone. However, each student learns at a different pace, and they may not all struggle at the same time. Thus, these transitions may occur not all at the same time for everyone in the classroom, and thus we refer to them as dynamic transitions or dynamic pairing. And these dynamic transitions are not fully pre-planned, but are instead determined opportunistically based on students' learning situations. Thus, they may be more personalized to each student's unique situation. However, orchestrating this kind of dynamic switching in classroom has been recognized as a major challenge in teaching practice. Just as the conductor needs to carefully manage an orchestra in order to play great music, a teacher also needs to carefully manage various learning activities in order for the class to progress well. Classroom orchestration refers to the management of these learning activities. The main research questions that this study targets at is whether such a technology ecosystem makes it feasible for teachers and students to achieve dynamic transition in classroom. A wide range of orchestration tools are designed to help lessen teachers' load in classroom management. These tools have, however, typically been designed with the assumption that a class of students would progress through instructional activities in a relatively synchronized manner. Furthermore, existing orchestration tools generally focus on enhancing teachers' awareness by providing teachers with real-time analytics, and few provide intelligent support for teachers in the moment and dynamic decision-making, with some exceptions. What's new and unique about our technology ecosystem is that it can support monitoring students' real-time learning progress in both individual and collaborative modes. And it aims to support dynamic transitions between these two modes. And it offers AI-generated pairing suggestions regarding whom to team up, but still leaves the full control to teachers over any pairing decisions. We designed the tools based on constant feedback from teachers' needs in their daily teaching, and through human-centered user research, such as interview, survey, and co-design sessions with teachers. The ecosystem has three components. The first component is a standard equation solving tutoring system which supports mastery learning. The second component is named APTA, and it extends the individual tutor's functionality to support collaborative learning as well. And these two students would respectively take the role of solver and tutor. And the solver will solve the math problems and can seek help from their partner. And the tutor will help the solver through step-by-step evaluation and feedback via the chat window. The goal for dynamic transition means that students will bounce back and forth between individual and collaborative tutoring systems. The third component is also the new component in this ecosystem. It's a new teacher-facing orchestration tool named PairUp, co-designed with more than 18 teachers through iterative human-centered prototyping sessions and testing sessions. It can display students' learning progress and skill mastery level in both individual and collaborative modes through visual representation such as progress bar, skill bar, and learning status icon. Once the teacher selects the pairing policy, it provides AI-based pairing suggestions for the teachers on whom to team up. either randomly or based on their knowledge level. Despite the system's suggestions, teachers still have the full control to override the suggestions and make the final pairing decisions. Teachers can decide which assignment to select for the given pair and when to pair or unpair students. To study whether the tools can adequately support teachers to manage the dynamic transitions, we conducted an in-person classroom study in a suburban public school near Pittsburgh, with 5 middle school math teachers and 199 students participating from 11 classes. One teacher teaches special education with 7 students who have an individual education program. In the classroom study, after a short video tutorial, students would start with individual equation solving, and then the teachers would pair them up as teachers wished in the ways that they find most natural. When students were done with the collaborative assignments, or when they were unpaired by the teacher, they would switch back to their individual work. We analyzed students' log data in system and teachers' interview data. During the 22 class sessions, there is a total of 210 collaboration episodes that happened. Each collaboration episode is defined as 2 students who team up to work collaboratively on one assignment. There's on average 18 episodes in each classroom during the duration of the study. Since all the teachers initiated this collaboration episode, this is also an indicator of the feasibility of orchestrating such dynamic transition in their classroom. The teachers generally were able to use the orchestration tool autonomously, and similarly, students were able to work with tutoring software. All participating teachers stated that they see pedagogical value in dynamic transitions. However, the special education teachers expressed that transitioning between different learning activities may be challenging for her students. Still, all 5 teachers reported being likely to use such a technology ecosystem in their regular classrooms. Future work will further analyze students' learning process during these dynamic transitions and further improve the tools as our understanding on how to support teachers continually evolve. As researchers start envisioning more sophisticated and personalized interaction in future smart classroom, fluid social transitions become an interesting issue to study. Our study provides insight into what orchestration tool functionalities makes it feasible for teachers to manage dynamic transitions between individual and collaborative learning. We contributed a technology ecosystem and a feasibility study in classroom. The technology ecosystem has a combination of support for monitoring students' real-time learning progress in both individual and collaborative learning modes, AI-generated pairing suggestion, and full control by teachers owing the pairing decisions. The ecosystem will support further research into the value of the dynamic transitions, including how they affect students' learning outcome, compared to, for example, pre-planned transitions. This exploratory study brings us one step closer to the vision of the future smart classroom, where students transition dynamically between different learning modes at moments that such transitions may be most helpful. Thank you for listening to my talk, and I'm happy to take any questions you may have.